Let's start with the second part of the GAN. So, as we have already seen, GANs are to represent the cutting edge approach to generative modeling within deep learning, often leveraging architecture like convolutional neural network. The goal of generative modeling is to autonomously identify patterns in input data, enabling the model to produce new examples that feasibly resemble the original dataset. Deep learning has found numerous applications in the industries. Neural networks are being widely used in almost every business sector, such as healthcare, finance, e-commerce. These neural networks also solve business problems. GANs are a powerful class of neural network that are used for unsupervised learning. They are adversarial training to produce artificial data that is identical to actual data. GANs are made up of two neural networks, that is discriminator and generator. The generator attempts to fool the discriminator, which is tasked to with accurately distinguishing between produced and the genuine data by producing random noise samples. GANs are proving to be highly versatile artificial intelligence tools, as evidenced by their extensive use in image synthesis, style transfer, and text-to-image synthesis. They also have revolutionized generative modeling. The two models are known as generator and discriminator. They compete with each other to scrutinize, capture, and replicate the variations within a dataset. GANs can be used to generate new examples that plausibly could have been drawn from the original dataset. Let us try to understand with a real example. There is a database that has a real 100 rupee note. The generated neural network generates fake 100 rupee notes. The discriminator network will help identify the real and the fake notes. So what is generator? A generator in GANs is a neural network that creates fake data to be trained on the discriminator. It learns to generate plausible data. The generated instances become negative training examples for the discriminator. It takes a fixed length random vector carrying noise as input and generates a sample. The main aim of the generator is to make the discriminator classify its output as real. Thus, the output generated by the GAN that trains the generator includes noisy input vector, generator network, which transforms the random input into a data instance, discriminator network, which classifies the generated data, generator loss, which penalizes the generator for failing to dolt the discriminator. The backpropagation method is used to adjust each weight in the right direction by calculating the weight's impact on the output. It is also used to obtain gradients, and these gradients can help change the generator weight. Now let's understand what is discriminator. The discriminator is a neural network that identifies real data from the fake data created by the generator. The discriminator's training data comes from the different two sources. The real data instances, such as real pictures of birds, humans, currency notes, etc., are used by the discriminator as positive samples during training. The fake data instances created by the generator are used as negative examples during the training process. While training the discriminator, it connects a two-loss function. During discriminator training, the discriminator ignores the generated loss and just uses the discriminator loss. In the process of training the discriminator classifies both real data and fake data from the generator. The discriminator loss penalizes the discriminator for misclassifying a real data instance as fake or fake data instance as real. The discriminator indicates its weights through backpropagation from the discriminator loss. through the distributor network. Let us now try to learn how GAN works. GANs consist of two neural networks. There is a generator G and a discriminator D. Both of them play an adversarial game. The generator's aim is to fool the discriminator by producing data that are similar to those in the training set. The discriminator will try to not to be fooled by identifying fake data from the real data. Both of them work simultaneously to learn and train complex data like audio, video or images files. The generator network takes a sample and generates a fake sample of data. The generator is trained to increase the discriminator network, probably for making mistakes. Below is an example of GANs trying to identify if the 100 rupee notes are real or fake. So first, a noise vector or the input vector is fed to the generator network. The generator creates fake 100 rupee notes. The real images of 100 rupee notes stored in the database are passed to the discriminator along with the fake notes. The discriminator then identifies the notes as classifying them as real or fake. We train the model, calculate the loss function and at the end of the discriminator network and backpropagate the loss into both the discriminator and generator models. Mathematical equation. The mathematical equation of training a GAN can be represented as shown below. That is, G is generator, capital D is discriminator, P data is distribution of real data, PZ is distribution of generator, small x is sample from P data, small z is sample from PZ, dx is discriminator network and gz is generator network. So with this understanding, let's learn the next topic on what are GANs, training a GAN. Steps of training GAN: define the problem, choose the architecture of GAN, train discriminator on real data, generate fake inputs of the generator, train discriminator on fake data, train generator with the output of the discriminator. Let us now look at the different types of GANs which we have seen earlier. Now, vanilla GANs. Vanilla GANs have some minimax optimization formulation where the discriminator is a binary classifier and uses sigmoid cross entropy loss during optimization. The generator and the discriminator in vanilla GANs are multi-layer perception. The algorithm tries to optimize the mathematical equation using stochastic gradient descent. Deep convolution GANs. DC GANs support convolution neural network instead of vanilla neural network at both discriminator and generator. They are both stable and generate better quality images. The generator is a set of convolution layers with fractional strided convolutions or transpose convolutions. So it upsamples the input image at every convolution layer. The discriminator is a set of convolution layers with strided convolutions. So it down samples the input image at every convolution layer. Conditional GANs. Vanilla GANs can be extended into conditional model by using extra label information to generate better results. If CGAN, an additional parameter y, is added to the generator for generating the corresponding data, labels are fed as input to the discriminator to help distinguish the real data from the fake generated data. Super resolution GANs, that is SR GANs, use deep neural network along with the adversarial network to produce higher resolution images. SR GANs generate a photorealistic high resolution image when given a low resolution image. Now that we have understood what are GANs, let's look at some of the important applications of GANs. Application of GANs are: with the help of DC GANs, you can train images of cartoon characters for generating faces of anime characters as well as Pokemon characters. GANs can be trained on the images of humans to generate realistic faces. The faces that you see below have been generated using GANs and do not exist in reality. GANs can build realistic images from textual descriptions of objects like birds, humans, and other animals. We input a sentence and generate multiple images fitting the description. Thank you.